Puppaya. The genetically modified papaya plant is resistant to prevent the papaya ring spot virus. Corn. Genetically modified corn produces its own pesticide against rootworms and corn borers. Arabica rice is a drought-resistant variant developed by conventional technique. The roots of the plant grow 3 times longer, enabling better absorption of water and air circulation. Hence, the plant consumes only half the water needed compared to the conventional varieties. In addition, it can now be directly seeded into farm. Bacterial Belite resistant rice. Marker assisted back crossing. Marker assistant back crossing. MAB technique for Belite resistant introduced from the other rice variant into Jal Magna rice enables resistance to bacterial Belite caused due to submergence and survive of flooding. The introduced genes generate immune trigger toxic compounds to release enzymes that inhibit the growth of bacteria. Natural mutations. Deeper water rice has a rare natural mutation of semi rough genes SD1 that allows the rice plant to grow in length to rise above the water surface to survive long durations floods. The gene has been isolated to develop new rice varieties that can survive long-term flood conditions. Biofortification golden rice. ಎಲ್ಲ ರೈಸ್ ಯಾವ್ಯಾವ ಥರ ಮಾಡಿದಾರೆ ನೋಡಿ. Golden rice is a staple food of a large population in the world. Rice eaters have found to have vitamin A deficiency. To solve this problem, rice variety with inbuilt vitamin A, also called the golden rice, has been developed using genetic engineering technique. Golden rice is found to be effective in supplementing vitamin A. Golden rice. Rice is the world's second most important cereal crop after wheat. Rice feeds more than half of the world's population. Many different traditional and biotechnological methods of cultivation have evolved over centuries. New high-yield varieties have been developed by scientists. Explore some of the rice variants developed using different biotechnological methods. Aqua Bounty salmon. This new salmon is genetically engineered to grow larger in short time compared to normal Atlantic salmon. Both fishes shown at 18 months of age. Normal salmon average weight is 1.3 kg. Average length is 13 inches. Genetically modified salmon. Average weight is 3 kg. Average length 24 inches. GM goat. Gene that helps spider to produce silk has been inserted into the DNA of ordinary goat to extract silk from its milk. Silk from goat. GM code. Pig. Genetically modified pig have altered genes to produce phytates in their salivary glands to help digest phosphorus in their food. The excreta of pigs has less phosphorus, which is soil and water pollutant. Embryo transfer. Sperm of a bull from high milk yield herd. Bull cow. Cow is artificially inseminated with the sperm. Zygotes develop into embryos in cows and then removed from the uterus. Embryos are placed in the uterus of foster mothers, offspring of the high genetic merit. Embryo transfer technique is used to increase the reproduction rate of cows and buffaloes. Embryos of indigenous bovines such as Shavival, Gir, Red, Sindhi, Mongol, Dioni, and Magpur are transferred into surrogate cows with specific hormonal treatment. Polycell stimulating hormone to cause multiple follicles to ovulate. After 7 days, the artificially inseminated embryos are infused out from the donor's uterus and transferred into the recipient cows. On an average of 10 to 15 viable embryos can be produced from one donor in a year, which and transfer to a recipient results in birth of 3 to 5 calves. Deep water rice. Deep water rice. Deep water. Natural material. Deep water rice. Natural to change deep for variety of other techniques. Arctic apple. ಇದು potato. Genetically modified potato. 60% more protein. VMA 1 chain. Amaranth aluminum 1. BT cotton, genetically modified cotton. Genetically modified papaya. Ring spot virus. Genetically modified corn. Rootworms and corn horse. Salmon fish, genetically modified salmon fish, Bounty salmon, Chinook salmon, ocean boat, silk breeding goat. I can give, instead of milk, giving silk. GM goat. Phosphorus. Neuropig. genetically modified pigs. Transgenic soyabeans. Brinjal. Very funny seed. Brinjal. ಅಲ್ಲ ಇವಾಗ ಜೆನೆಟಿಕಲಿ ಮಾಡಿಫೈಡ್ ಅಲ್ಲ, ಜೆನೆಟಿಕಲಿ ಮಾಡಿಫೈಡ್ ಮಾಡಿ ಏನಾರ ಉಲ್ಟಾ ಪಲ್ಟಾ ಮಾಡ್ತಾರೆ. ಬಯೋಟೆಕ್ಲಿ ಫಾರ್ ಹೆಲ್ತ್, ವ್ಯಾಕ್ಸಿನು, ಪೆನ್ಸಿಲಿನ್, ವರ್ಲ್ಡ್ ಫಸ್ಟ್ ವಂಡರ್ ಡ್ರಗ್. Biotechnology contributes towards public health with effective diagnostics and treatment measures. About 400 of biotech drugs products targeting more than 200 diseases and vaccines are currently in clinical trials. Oh. Vaccines contains microorganisms or virus in a weakened or killed state, administered to a person to prevent the sickness from infection disease. Vaccines have been developed to protect against more than 25 debilitating or life-threatening disease, including measles, polio, tetanus, diphtheria, meningitis, influenza, typhoid, and cervical cancer. Penicillin, world's first one-time drug. Alexander Fleming, Scottish scientist, discovered the penicillin accidentally when a penicillin mold grew in the culture of Staphylococcus bacteria. Fleming found all the bacteria around the mold were killed as it acted as an antibiotic. He proposed to be used as antiseptic in wounds. Edible vaccines, food to fight disease. Edible vaccines are genetically engineered plants whose edible parts contain proteins that can function as oral vaccines. It is a safe, inexpensive and readily available oral vaccines. Technology vaccines. Diabetic. Pancreas doesn't produce required quantity of insulin in the body. Pancreas produces insufficient quantity less insulin and is not recognized by the body. High blood glucose levels can damage blood vessels and organs. Due to a lack of insulin, glucose is not digested, resulting in a high blood glucose level. Deep tank fermentation, large scale fermentations were developed to make penicillin drug. The productivity of penicillin is about 80,000 1 lakh units milliliter presently. Humulin, world's first bioengineered hormone. Humulin was the first lab-made human insulin tried for diabetes. It was created by inserting human insulin gene into E. coli bacterial host, which multiplied to provide endless supply of human insulin. Earlier, insulin was extracted from pancreatic glands of pigs and cows. It took around 2000 kgs of pig parts to produce 794 grams of purified insulin. Insulin ನೋಡಿ ಪಿಗ್ಗು ಕವಿಂದಲ್ಲ ಇನ್ಸುಲಿನ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು 2000 kgs pig parts to produce 794 grams of purified insulin. 2000 kgs ಎಲ್ಲೈತೆ 794 grams ಅಲ್ಲಿದೆ. monoclonal antibodies MABs are antibodies that are highly targeted, specific in actions and recognize only one side of antigen. Mouse is a common source of monoclonal antibodies. Mice are immunized with antigen of interest, and the resulting immune cells are harvested from the spleen and fused to an immortal myeloma cell line to create hybridoma, which is a long-term source of antibodies. MAB is used for cancer treatment, make it easier for cells of the immune system to find cancer cells. Herceptin is a monoclonal antibody approved for breast cancer treatment. Herceptin. Nanomedicines is a highly specialized medical treatment which involves development and introduction of nano devices into human systems to repair damaged tissues, infections or cancerous cells, or monitoring of vital parameters such as BP, glucose levels. Nanomedicines deliver medicines, find and treat disease, repair damaged cells. Nanomedicines is highly specialized medicines treatment which involves the development and introduction of a nano device into human system to repair damaged tissues, infection or cancer cells, or monitoring of vital parameters such as BP, glucose levels. Nanomedicines. One human hair is approximately 80,000 nanometers wide. Nanoparticles are between 1 and 100 nanometers in diameter. Nanoparticles are between 1 and 100 nanometers diameter. 80,000 medicine. Gene therapy involves adding, removing or altering defective genes of patients to cure a disease or to improve body's ability to fight a disease. Gene therapy holds promise for treating a wide range of diseases such as cancer, cyst, fibrosis, heart disease, diabetes, hemophilia and AIDS. Researchers use a virus as a carrier to carry the genetic material into the cells. An illustration to show the transfer of a new gene into the nucleus of a cell via viral vector. New gene viral binds to cell. Vector packaged into vessels. Cytoplasm. Vessel breaks down, releasing vector New gene injected into nucleus. Oh, gene therapy. Healthcare and biotechnology. Biotechnology has played a major role in the area of healthcare through development of modern diagnostic techniques, manufacture of drugs, hormones, vaccines, and other biochemicals. The Human Genome Project has expanded our abilities to detect, diagnose, and treatment of diseases. Biotechnology holds many opportunities in future for advancement in promotion of human healthcare. Uh, Biotechnology for industry, flavor and fragrances, vanillin flavor. Oh. Molecules is prepared through fermentation by incorporating the genome of baker's yeast, sugaring, and microbes to give out vanillin using readily available sugars as its main food source. Future of clean energy biofuels, bioethanol is renewable energy source created by fermenting the sugars and starches found in plants. The most common plant sources are sugarcane and grain crops, but ethanol can also be produced from potatoes, corn, beets, and rice. Cheese making. Cheese manufacturing usually relies on the enzymes rennet, which contains chymosin. Traditionally, it is obtained from the stomach of milk fed cows. However, recombinant DNA of chymosin is genetically and structurally identical to the original enzymes and is produced in large quantities at a lower cost. Industrial biotechnology uses microorganisms and enzymes to produce products that are useful to broad range of industrial sectors like chemical, pharmaceutical, nutrition, pulp and paper, textiles, energy, and new materials like biopolymers and bioplastics. Industrial biotechnology processes require relatively mild reactions conditions such as moderate temperature, pH, thus reducing the energy requirements and contributing to economical and production and sustainability of industries. Anti-browning, white button, mushrooms, CRISPR technology has been used up. CRISPR technology has been used to modify the genes responsible for browning the white button mushrooms. This method deletes specific genes that code for the synthesis of polyphenol oxidase, PPO, and reduces browning in the altered white button mushrooms by 30%. Bioplastics are made using innovative method for turning starch of fructose into biomaterial that can be converted into a number of high value bio-based chemicals or materials. Biofabric. Sorona is a soft fiber that does not need to be woven with another fiber for softness. It's dyeable and capable of holding color. It is extremely stain resistant while exhibiting a high strength, stiffness, and dries up faster. Sorona soft fiber, biofabric, high fructose corn syrup, HFCS. High fructose corn syrups is a sweetener. It is made up by the chemical and enzymatic hydrolysis of corn starch, corn syrup containing mostly glucose followed by the isomerization. It acts as a flavor enhancement for both sweet and spice items such as baked goods, fruit fillings, tomato, ketchups, beverages, breakfast, and cereal bars. Enzymes for denims. For design, amylases, palcozyme, ultra palcozyme plus for bio-polishing and denim finishing, cellulose, Palcofield, Palcosoft, Palcostone, etc. for bleach cleanup, catalyze, Palcoporox for biosourcing, multi-component enzyme, Palcoscore. Toothpaste, certain brands of toothpaste and mouthwash incorporates multiple enzyme systems that helps supplement the natural antibacterial system in the mouth. Denim bleach. The popular stonewash look or one look of denim jeans is obtained by rubbing the pumic stones soaked in sodium hypochlorite or potassium permanganate oxidizing agents on the fabric. Biostone washing. Enzymes such as cellulose are used to upgrade and release dye onto the fabric surface. When the desired color is achieved, the enzyme's action is stopped by changing the temperature or alkalinity of the bath. Microbial by-production involves genetic modification of Escherichia coli bacteria by inserting genes to produce indigo dye. Or biofabric. Toothpaste and mouthwash have multiple enzymes to support natural antibacterial activity. Example: glucoamylase hydrolyze starch reduces in mouth to produce glucose. Hydrolyzes starch reduces in mouth to produce starch residues in mouth to reduce other starch residues in mouth to produce glucose. Lactoperoxidase prevents plaque formation. Toothpaste contain natural lactic acid bacteria that accumulate at pathogen sites in teeth to enable removal of pathogens in mouth while brushing. Bio toothpaste. high fructose corn syrups, HFCS, high fructose corn syrups is a sweetener. It is made by the chemical and enzymatic hydrolysis of a corn starch corn syrup containing mostly glucose followed by the isomerization. It acts as a flavor enhancement for both the sweet and spice items such as bagged fruit fillings, tomato ketchup, beverages, breakfast, and cereal bars. All are bioplastics. All are bioplastics. Anti-browning white button mushrooms. Mushrooms, antibiotic mushrooms. Protein sequencing. Protein sequencer. Called to see AstraZeneca, a research foundation India. Pre-activation. Indian contribution to biotechnology, 18% bioagriculture, 15% bioindustrial, biofuels, enzymes, biopolymers, biopharmaceuticals, biosimilars, vaccine, insulin, regenerative medicines. Key stakeholders of India: Department of Biotechnology, Ministry of Science and Technology, Department of Science and Technology, Ministry of Science and Technology, Biotechnology Industry Research Assistance Council, BIRAC, Council of Scientific and Industrial Research, CSIR. Association of Biotechnology-led Enterprises, ABLE, Central Drugs Standard Control Organization, CDSCO, Ministry of Health and Family Welfare. ಎಲ್ಲ ಲೈಕ್ ಬಯೋಟೆಕ್ನಾಲಜಿ ನೋಡಿ, ನ್ಯೂ ಡೆಲ್ಲಿ, ಅಹಮದಾಬಾದು, ಕಾನ್ಪುರು, ಲಕ್ನೋ, ಕಲ್ಯಾಣಿ, ಕೋಲ್ಕತ್ತಾ, ಕಟಕ್, ಹೈದರಾಬಾದು, ಬೆಂಗಳೂರು, ಮೈಸೂರು, ಕೇರಳ, ತಿರುವನಂತಪುರಂ, ಪುಣೆ, ಮುಂಬೈ. ಸೊ ಇಲ್ಲೆಲ್ಲ ಬಯೋಟೆಕ್ನಾಲಜಿ ಇರೋ ಜಾಗ ಎಲ್ಲ ಇವರು ಮಾಡ್ತವ್ರು. ಬಯೋ ಅಗ್ರಿಕಲ್ಚರ್, ಇಂಡಿಯನ್ ಅಗ್ರಿಕಲ್ಚರ್ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್, IARI, ನ್ಯೂ ಡೆಲ್ಲಿ, ICAR, ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಹಾರ್ಟಿಕಲ್ಚರಲ್ ರಿಸರ್ಚ್, ಬೆಂಗಳೂರು, ಕರ್ನಾಟಕ, ನ್ಯಾಷನಲ್ ರಿಸರ್ಚ್ ಸೆಂಟರ್ ಆನ್ ಮೀಟ್, ಹೈದರಾಬಾದ್, ತೆಲಂಗಾಣ, ಅಗರ್ಕರ್ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್, ಪೂನೆ, ಮಹಾರಾಷ್ಟ್ರ, ನ್ಯಾಷನಲ್ ಡೈರಿ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್, ಕರ್ನಲ್, ಹರಿಯಾಣ, ಇಂಡಿಯನ್ ವೆಟನರಿ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್, IVRI, ಬೆಲ್ಲಾರಿ, UP. Bareilly, fundamental knowledge, postgraduate teaching biotechnology in India, regional stations, key biotechnology segments in India. Indian contribution to biotechnology. Indian biotechnology sector comprises of biopharmaceuticals, bioservice, bioagriculture, bioindustry, bioinformatics. India has the third largest biotechnology base in Asia Pacific regions. Indian biotechnology companies are known for their products in biopharmaceuticals and bioagriculture. The biotechnology industry in India comprises of about 600 plus crore companies 2,600 plus startups, plus 47 biotechnology industries, research assistance council, BIRAC, supported incubators. India accounts for about 20% of global exports in terms of volume in generic drugs making. At the largest producer globally, it has the second highest numbers of US Food and Drug Administration, USFDA. Approved manufacturing plants. Immunotherapy uses a person's own immune systems to recognize and destroy cancer cells. Most of the immunotherapies therapies use cytotoxin T cells, which recognize and kill the cancer cells, displaying specific antigens on their surface, helping macrophages to eat cancer cells. Macrophages are immune cells that eat foreign substances, unhealthy cells. Some cancer cells express certain protein on their surfaces that prevent the action of macrophages. Blocking the activity of these cells enables macrophages to kill the cancer cells, harnessing the dendrite cells to activate T cell immunity. Engineering natural killer cells to target cancer. Natural killer cells are innate immune cells that kill cancer cells by releasing enzymes that form small holes in the cancer cells and destroy them. These are being modified to increase their capacity to kill cancer cells. Dendritic cells, T cells, CTLA4 inhibitor, cancer cells, PD1. The CTLA4 checkpoint protein prevents dendritic cells from priming T cells to recognize tumors. The inhibitor drugs block the protein to enable dendritic cells to act on cancer cells. The PD1 checkpoint protein prevents the T cells from attacking cancer cells. The inhibitor drug allows T cells to act. T cells are isolated from patients. T cells transfer. T cells are stimulated or modified to recognize tumors. Immunotherapy. Clustered regularly intra-spaced short palindromic repeats, CRISPER. Clustered regularly intra-spaced short palindromic repeats. Clustered regularly intraspaced short palindromic repeats, CRSPR, and their associated proteins CAS display adaptive immune system in prokaryotes by integrating short sequences of invading genomes termed spacers. The spacers interspaced with repeats are expressed as small guide CRISPR RNAs, RNAs that are employed by CS proteins to target invader sequence on recurring infections. The ability of CRISPR CAS9 system to target DNA sequence using programmable RNAs has opened new avenues in genome editing with high potential in therapeutics. When a phage attacks, it injects its own DNA into the bacterium. The spaces of the bacterium CRSPR systems are copied into a string of RNA, which is then cut into short pieces called CRISPR RNA. If the phage DNA matches the CRSPR RNA, special CRISPR associated CS protein are dispatched to destroy it. CRSPR RNA. The case proteins and cut of the phage DNA guided by CRSPR RNA. By engineering artificial CRISPR RNA, scientists can direct gas to cut any genome in organisms. And by making strategic cuts, they can